Okay. I think we should be live in a second. Now, today's topics is more, sorry, it's a bunch more confusing stuff. Today's material is actually my least favorite stuff in all of JavaScript. I think we should be live in a second. Oh. It's, so I think what we're gonna do today is switch it up a little bit, because if we do all of this slides and then try to do an example, everyone's gonna just be done. You're gonna be like, oh, this, and we won't have fun with the example. So I think we should do the example first. The example is from yesterday. We never got to it yesterday, but we're gonna do the exercise where we make the node console or your JavaScript program, which will perform a card trick, which will let you see a pretty cool a pretty cool little program just all comes together from start to finish. It's going to be a fair bit of typing, but all of the stuff that we're going to use we've seen, except for the new keyword, which we're going to talk about in the lecture after, but just don't worry about it until we get to the lecture. All right, so I think let's get right into that. I'm going to show a demonstration of what the card trick is we're going to do with some real cards first. So here's the little table. We did the, this is like my real world example table. Okay. So, cool. Oh, okay. All right. Here's the way this card trick works. You have 21 cards in this trick, and they can be any cards in the deck. I just pulled these from a deck of cards. You deal them into 3 piles of 7 cards, but you do it like this. So you deal across, 3 across, and then the next one into each pile. So you're sort of shuffling them into 3 different piles, and each pile is going to end up with 7 cards. Okay, you can see all these cards. Cool. So now what you do is, Carolyn, there's no food in this example. This is only playing cards. So yeah, I don't think we have any other food-based examples. Anyway, here's how you do the trick. You tell the audience or somebody in the audience, you can only do this to one person at a time. So we'll do it out loud. How about? It's really not that hard of a trick or complicated. You ask the audience to say, to just think of one of the cards, look at the cards in here, and think of which one it is. So for the sake of example, we're not going to say, well, it's magic. Let's just say what the card is out loud, and I'll show you how the trick works. So who wants to pick one of these cards? And that'll be our card.
8 of hearts.
Okay, 8 of hearts. That will be our card. And what you do is you ask the person who picks the card, don't tell you what the card is. Now, we know it's the 8 of hearts because we're doing an example, but don't tell me what the card is. Which row is it in? Is it in this row, or this row? So you'd say it's in this row. What you do to do the trick is you take this pile, scoop it up. That's why they have to be kind of overlapping like this. You scoop up this one, you scoop up all 3, and you put the one that they said the card is in between the other 2 piles. And then you deal it again, but the same way. So it's 3 across, and then layer them like this until you get all 21. And then you just repeat the same thing. So we just saw the 8 of hearts is now in that pile. So when you ask, which pile is it in now? They'll say this pile. So you grab this pile, do the same thing. Put the pile they said in between the other 2 piles. and then you do a third time. Oh, whoops. They should be a little overlapping like this, makes it easier. Okay, and if you notice what's going on here, by this time, we've done this 3 times. We've dealt once, they've told us twice which pile it is in, we dealt 2 more times. By this time, I think the card should always be in the middle position of whatever pile it's in. And that's just because by continuously putting it in the middle of the other 2 piles, we're kind of like making it, we're sort of, eventually this card will end up right here if we do this enough, just because we put the whole pile in between the other 2, and because of how some of the multiplication works. I don't really know exactly, but it ends up here. If we do it 1 more time, it's going to go from here to here. So they would say this pile, and you could either immediately pick it out of the pile. It's the one with 3 on either side of it. Or you could do it 1 more time. Actually, I think at this point, yeah, you could do it 1 more time. And you wait for them to say the middle pile, basically. And this time, I think it will be in the middle pile and in the middle position of the middle pile. There it is. So it'll be right in the middle of all of the cards. And at this point, you can reveal it however you want. You could say, if they say it's in the second pile, you know it's the middle. So you could, count, you could put it together and pretend to like count to the card or whatever. But in any case, now you know it's that card and you can call it out. So that's it. That's the card trick. You can do this with your friends. They will probably say, wait a second, I just gave you a whole lot of clues to where the card is. That's not the best trick. And they're right. It's really not the greatest trick, but it's cool. And you can probably fool a bunch of people with it. So, you could try that. Anyway, the other thing about it is that it's a very simple trick to do. You don't have to like do any sleight of hand or special moves or anything. It's all just counting out the cards and picking the pile. So we can actually have the computer do this trick and present it to you and have you pick the cards and then it will reveal the card. So let's do that. All right, I'm gonna share my screen. Let's see. So this latest push, we've already got this yesterday probably, but just in case, if you go to GitHub Desktop, make sure you're in the right repository, little book, right branch, and you have all the latest. Again, this thing, discard. If you've got any changes you want to get rid of. Once you're here, you open in Visual Studio Code. And we're going to go to Cohort 2, Module 4, W7D1 card trick. Well, this is day 2, but we went over. So we're going to do the W7D1 card trick. And in order to get the terminal in the right place, the easiest way is Control-click on W7D1 card trick, open an integrated terminal. And then you can check that you're in the right folder by looking at the prompt right here. And we're going to build our card trick in the cardtrickbefore.js file. Now the finished code is in cardtrick after. If you don't want to look at it yet, won't spoil any of the surprise or any of the code. So I think the first thing let's do is just get ready to run this file, even though it's empty. I'll do node card trick before.js. And if you did it right, it won't print anything. It won't error. It'll just say there's nothing in the file. I'm done. So we're ready to go. We can put the whole card trick into this file. Now, in order to do this, if you notice, I put this file package.json, and let's do a little aside and talk about node modules and how you save them with package.json. Let's pause here. You don't have to type any of this code because we're all ready to go. I'll just demonstrate how I got this here. And just pause changing anything until I tell you we're going to pick up from where. The way you get these things here, let's just delete them and start over. So Node has its own system of what's called packages. These are bits of programming, programs, libraries, servers, all kinds of different kinds of programs that other people have written, and then they've uploaded and they've made available to anybody who uses Node. And you can install anything you want. As I think somebody mentioned in one of the channels, you can install this by doing, the dependency from the other one was prompt sync. So you could do npm I, which means install, prompt sync, and that would fix the problem. The program would say, I don't know about prompt sync. We're just installing that package. In order to manage our packages better, and this will be something that when we set up our React app, this will be all kind of started for you, but you'll be seeing this package.json, and you might be doing some of these commands to install new packages that you want to use. So in order to set all that up and get started, we're in the folder where we have our code, and we want to initialize a new package because this is a nice way to manage it. We're not going to publish this anywhere, but this is just what you do. So we would do npm init. This is to start a brand new package. We don't have, I don't have the file here because I deleted it. And then it'll prompt you with all kinds of little questions like, what's the package name? You can just hit enter to most of these. Version, description, nope. Entry point, it picked the first JS file. That's fine. It doesn't really matter. Test command, who cares? For now, we're not going to be doing any linking it to Git. Don't need really any of this. The license, that's fine. It's an open source license. That's okay. So I'll say, is this okay? Enter one more time. And well, it tells me I could upgrade my NPM, but I don't really care. So we're all set. Now we have this package.json. And this is where we can start managing our packages so that we can sort of distribute our thing as its own package. And then other people can easily get whatever dependencies our package might need. So in order to add a dependency now that we are in a folder that is a package, we can use npm and save whatever we install into this package.json file. And to do that, I'll do npm I, but I'll do -S, which is the same as --save, but I like the short version. And this means install, but also save this package to package.json. And I'll install the two packages we're going to need, prompt sync, and then a space, and you can add in as many packages separated by space as you want. So I will also put, what's it called? Cards. And the second package will be our, somebody else has made a deck of cards simulation so that we don't have to worry about all the different, combinations of card shuffling and all of that kind of stuff. It's pretty complicated. And a deck of cards is a deck of cards. So this person has made a simulation of a deck of cards, and they've made it available so anybody who wants to deal cards, shuffle cards, and do that simulated action with cards can just reuse their code. So I'll hit enter here. It's going to run some stuff. And it added some packages for me. But it also created a brand new file here called package lock, which is just kind of like a security thing. Don't worry too much about this. If you don't even know what this is, it's not going to help you be more secure at all. You might understand some of this stuff later in the program, but this is more advanced stuff. But what it's also done is it's changed the package.json to put 2 entries here in dependencies. Now you'll already see these if you didn't even delete the file to begin with. But this now means that if I save, I commit this, anybody else who downloads this, which means all of you, if you haven't done any of what I did, delete this, blah, if you listened, all you have to do at this point is run npm I, and this is something everybody should run in this folder. Just npm I, and you don't give it any package to install, but npm will know I should check for this file, and I should look for dependencies, and I should install everything that's in here. So if you see up-to-date, added or audited packages, found, that's 0 vulnerabilities, that's good. If you see something like this with some number of packages, probably 6, then you're all set. You're all set to go. Maybe 5. Maybe you'll see added 5, audited 6. But anyway, you can run this as much as you want. npm I, it won't break anything. It's just a nice thing to run if you're in a place that has a package.json and you want to make sure every bit of code you need to run your node program is pulled in and ready to go. And if you notice, it's actually made this folder here called node modules. And don't even worry about all of this stuff because it's going to be just all of the stuff you installed. And you can look through the code of the cards thing. Apparently we have something called ANSI regex, okay. Rand utils, strip ANSI. Okay, we got a bunch of random packages in order to make our dependencies work. We don't have to worry about this right now at all. We can just leave that folder alone and we're ready to go. So what this means now is, for example, if we go back to our card trick before .js file, we can immediately use these packages that we just installed. So I can say const, oh, what's going on in the chat?
So yeah, in my terminal, it came back how Gus's terminal came back. It said found 0 vulnerabilities, audited 6 packages. And it's up to date, but I don't have any of the node modules on the side.
Okay. It's possible that VS Code is just hiding that folder because you're really not supposed to mess with it. Okay. Let's do the next step. And if you get an error on the next step, then we need to fix it. If you don't see this folder, it's not necessarily a problem. It could just be VS Code doesn't show it. I don't know why it would be different than this is a fresh and brand new install, but we'll see.
Okay.
Okay, so in our card trick before.js, let's say const prompt sync equals require prompt sync. And then we run this, whatever this returns is also a function. We have to run it again. And this is taken right from our Yahtzee example. It's the same exact dependency. It's the same line of code. We can do sig int true. And this will at least let us interrupt the program with Control C, even though we're prompting for the stuff we need. So I'll paste, once we get to the first checkpoint, I'll paste everything in the pasted code. So if you get any of this wrong, you can just paste over it. Carolyn, you get invalid version. If you just hit enter, so you ran the code even though I said not to. you deleted the files. Okay. Could you? Yeah. We might have to leave you behind today. I don't know. Yeah. Let's I'll get to the check.
Oh, I didn't know we were supposed to. I thought you just figured it would be easier to watch. I deleted something.
Who knows? I don't know exactly what you mean by getting. It's complicated which context you're talking about.
In the
how about-
integrated terminal where you were getting
Yeah.
all the different, I was typing in the stuff you were typing in, then I got the stuff I put in the chat.
Yeah.
But anyway, whatever.
So here's what we should do. First of
All
all, you
vulnerabilities,
should
zero
go back to GitHub Desktop,
Okay,
get rid of all your changes, fetch the latest, go back to the W7D1 card trick, open an integrated terminal, and run just npmi and see if that works.
okay,
And ping us if not. And Karen, we could probably help in a breakout room. But anyway, we'll have a checkpoint pretty soon so that you can catch up if you need to do that.
yep.
Okay.
Thank you. Let's see, I got it.
Okay, so we have our prompt sync. This is exactly the same line as that we had in the Yahtzee example. Well, let me just make sure. Prompt sync, SIGINT, true. Yep. Okay. Get out of the way, Zoom. It's weird, like none of you see this little bar that pops up. So whenever you're sharing your screen, you seem like you're crazy, like you're moving the mouse around, there's nothing there, but I can see it. It's blocking my screen. Okay, so we get this prompt sync and we can test it right away and just make sure that we've installed everything and that we're ready to go by echoing back something that the user types in. So we'll say const test equals prompt sync, and we'll say what's up. Oh, what is up? Nope, question mark inside the string. What is up? And we will say console.log test. Just prompt for something and log it. And this will at least just check that we have this prompt sync require thing all correct and we're ready to use it. And so we don't have to, get hit by an error later and be like, which part of my program is broken? So we'll do node in the terminal down here. We'll run, we'll save it, make sure to save it. And we'll run node card trick before.js. And it will say, what is up? And it'll say, nothing much, you. And it will echo back, nothing much, you. So everything's working. We got our prompt, it takes in the string we give it, and we are able to use that now as a variable. So we're ready to prompt things. The other dependency we need is the cards that we're going to use to our deck of cards dependency, so that we don't have to make our own version of a deck of cards. That's pretty complicated. So we'll say const, and then I just got this from the documentation. You need to wrap this, you need to put this dex variable into an object. Actually, I just realized this is one more thing in this program that we haven't seen yet. I'll explain this in a second. So const open curly brace variable will be called dex, and we'll assign the value of require cards in the string like this. And then we might as well just also test this. So we'll console.log, we'll comment this out, and we'll console.log dex to make sure we got something. And I'll run. Okay, standard deck, euchre deck. So you can do tarot deck, it looks like. Baraja, Piquet deck, interesting. It's got all kinds of decks of cards. So if you wanted to do like a tarot program, you could do that. So this thing here, this is kind of a newer part of JavaScript, and I think I might have just forgotten to explain it. But this is weird to see on the left-hand side of an equals. We have this kind of object-looking thing, which is wrapped in curly braces, and we're assigning to it. Like it's a little strange, but this is it's a shortcut, and it's basically the same as saying if we did const cards, require cards, then dex would be cards.dex. So this thing here is an object that has a property inside of it called dex. And rather than having to do this, where we grab the whole object, we save it somewhere, or we do like dot cards, or sorry, dex, like this, and we use the property here. Basically what I'm saying is if we did require this, we get an object, here's the property we want. You can also say, well, I want to assign a bunch of things to different properties of this object. Right now, we only want one. So we're just going to say dex. And this is called object destructuring. I'll write this in, if you want to look into this more. I don't know if we'll cover it this week, but this is a newer JavaScript thing called object destructure. Sure. Object destructuring. And let's make sure that is actually what I think it is. Destructuring assignment. Yeah, so the first thing, of course, is this MDN thing, which will go into ludicrous amount of detail, technical words and everything. But if you want some, this should give you some examples. You can do the same kind of thing with arrays. And anyway, you know, let's not worry too much about that right now. It's a newer technique. It's pretty nice as a shortcut, and it has its good uses. You'll probably see examples of that when you do React. But that's why these are on the left side of the equals. In order to make it less surprising, let's just do it this way. So this is an object, you get the dex, it's dex. Less surprising. Okay. So we have both of our dependencies. They both have imported correctly. We've logged them. We've made sure that that is ready to go. And so we are now ready to make our card trick. The first thing we can do is we can make a dictionary just for printing out the symbols for each suit, because that's something we know we're going to have to do. We're going to want to turn the word clubs into the little symbol for clubs. We could say blank of clubs in like a long string, but it's really nicer to just show it like you do show it a card. So we'd have 4, and then I'm going to steal the whole thing from the after site. So I'm just going to copy this whole suit symbols because I don't want to have to figure out how to type that weird character. That's like a Unicode. So I'm going to copy that whole thing. A little bit of cheating. It appears VS Code has decided that this file will have 4 spaces per tab. And I didn't even ask for that. But I'm not going to fight it, I guess. I think you can change that default behavior with, let's see, preferences. I'm not even going to care. Let's see. Oh, space, the number of spaces a tab is equal to. Cool. So you can do file or code, preferences, settings, and then scroll down a little bit and change. If you prefer to have your tabs be 2 spaces, you can do that. I prefer that, so I'm going to do that. But don't worry if it's, oh man. Try reopening. Maybe it's just going to be 4 and there's nothing I can do about it. Oh, it's 2. I reopened the file and it's back to 2. I had to scoot them back, save the file, close the file, reopen the file, scoot them forward, and then it was like, okay, you can fine, you can have two spaces. Don't worry about it if it's 4. It's fine either way. I just like having a little more space horizontally, especially because the text is really big, because I want everybody to be able to read it. So it's 2 spaces. Okay. Where did I copy the symbols from? It's everything, pretty much the whole code that we're going to write, almost exactly the same code. It's in cardtrickafter.js right above it. So right near the top of that file, this file, it's right next to card trick before, and it has this whole section, suit symbols. It's an object. The keys are clubs, diamonds, spades, and hearts. And the values are strings that contain these little Unicode characters, which look like the suit symbols. So I just copied it right out of there. Yep. Okay. So now we have the suit symbols. We could say console.log 6, the string 6, sure, plus suit symbols dot clubs. And the all capital with the underscore is a convention I often use when you know this is just a global, it's a constant. It's never going to change. And it has nothing to do with the exact way you're running your program or the user of your program. Suit symbols will always map clubs to here. So I'm using this syntax. That's the answer, Carolyn. It's all uppercase with the underscore because it's the syntax I like to use for things that are constant. Not everybody always does this. It's upper snake case, I guess, is what you'd call this. It's snake case, but everything is capital. It's just my preference for things that are not going to change, that are not, definitely const, definitely things that should never change. You should never assign to this. You should never assign to anything like this if it looks like that. In my conventions, in my style. So if we log the string 6 plus the symbols dot clubs, we should get a nice little version of what we can recognize as a 6 of clubs. So that's how we'll print out our cards. We won't try to make patterns of clubs or whatever, make it look like a real card. We'll just abbreviate to say, this means 6 of clubs. Okay, so we have our suit symbols ready to go. And we can start making functions that are going to break apart our, so we can, while we're writing this, we can imagine that here's one piece of the program that really should be all self-contained within one function, because it's achieving one part of our card trick. And the way that you break it apart into functions might, depend on a lot of things. There's really no, like we saw yesterday, there's really no right way to break stuff up into functions. But it's really just, using your best judgment and trying to sort of predict what things you're going to want to group together and all give the same name. And you'll kind of understand what I'm talking about as we get into this. So let's make our first function will be a way to start dealing our cards from nothing. This will take no arguments. This function will not have any arguments, and it will give us back our 3 rows of 7 cards. And the format we will give the cards in is going to be an array which has 3 items in it, so 1 element per row. And each element in our array will be another array that has 7 elements in it. So we will have an array that sort of matches the shape of the cards you saw on the table. We'll have 3 this way, and each item in our array will have 7 of its own items. So we can do that by using our dex thing to deal out our cards, and organize them into the array shape that we want for our trick. So we'll define this function. We'll call it initialize card rows. It doesn't take any arguments because this is how you get the card rows from nothing the first time. We're going to define a variable, a const here called dec, and we can put it inside the function because remember I said yesterday that you kind of always want to contain the variables in the innermost scope where they need to be. And we only really need to deal out new cards from a fresh deck of cards in this function. Everything else in this trick is manipulating the cards we already have been dealt, shuffling them around. And so we can basically say we'll only initialize our deck, our deck variable will be scoped inside this function. And the only thing it returns will be the cards we're going to use. Everywhere else, we don't really care about the rest of the deck. So we're not even going to define a const deck out here. We'll say const deck equals new. And this is, we'll talk about this in the lecture today. But this is a way to use it. Again, I got this from the documentation for the deck of cards thing that we're using. So the way you do this is dex and VS Code. As soon as you press the dot here, you'll notice something pretty nice, which is also true of a lot of other libraries. When you start using code which is well written and is nicely documented, is nicely annotated, then VS Code can understand a whole lot about what you're doing. And you'll find that you don't actually have to type everything out exactly. In this case, I'll back it up, I'll do it again. As soon as I type dex, it knows there's something called dex I've gotten from here. And more than that, it knows what's inside dex. So as soon as I press the dot to say I want dex dot something, it's going to actually tell me, hey, these are the things that are in dex. And I can just pick them with the down arrow key. So I want a standard deck. I just want a regular deck of cards. I'll go to standard deck and I'll just hit enter and it fills it in for me. Now, anytime you use this new keyword thing, for weird reasons, you're gonna want to run the thing it is. It's a function, so we gotta run that. And that's all. That gives us a deck of cards. Let me do I'll do a checkpoint after this. I'll paste what I have when I'm finished with this function into the chat. So if anyone has a typo, you can just grab it out of Slack and then pick up from there. Now here's what we want to do. The first thing we got to do is this is a brand new deck of cards, so we need to shuffle it. And this is a simulated deck of cards. So it has deck dot shuffle. And VS Code has given up on that. It does not understand. And if you hover over deck, it's because it has no idea what's in this deck. It knows that dex has all of this, but each one is what's called the any type, which is sort of a TypeScript-y thing. And it's not going to give us any more help, which is a bummer. But for other libraries that are better annotated, this one is probably just somebody did this as a hobby, but other libraries that are better annotated, you might get better information when it would be really nice if when you put the dot, it would say, one of the things you can do is shuffle. But you're going to have to trust me because I've already done this example and it works. So that's a bummer. One other reason to maybe in the future consider learning TypeScript is because the code you write will work very nicely with this kind of thing, where you do the dot and it tells you, it understands the rest of your code and can help you write more code that uses it faster and with less chance of typos, because I didn't have to type any of this. It just finished it for me. This one, not the case. It gives up. It says, well, You don't get any more help, which is okay. Okay, so we now have shuffled our deck, and we have the ability to draw. We can call another method on here called draw, which I just know because I've already done this. I'm going to first make a new container, which will hold the rows of cards, our 3 rows of cards. So this will be called const card rows, and this will be an empty array. And I'm going to draw 3 different arrays of 7 cards 3 times, and I'm going to push each one onto the end of this array. If you remember the push method, this will allow us to end up with a array that has 3 rows, and each row will have 7 cards in it. So we can do card rows dot push deck dot draw, and you pass it the number to draw. And I'll just copy this line 3 times. So here's our 3 rows. Each one is, we draw 7 cards. And then we're going to return our card rows. So this function now does everything that it's intending to do. It takes no arguments, and it's going to return our new card rows, a brand new set of 3 rows that each have 7. And now everywhere else in the program, we can forget about this. And in fact, if you prefer, I don't do this. I don't like to do this because I see it as a bit of a crutch. But if you prefer, once you're done with your function and you know you don't care what's in it, you can click this, you can hover over right next to the function word. And there's this little down arrow, and VS Code will let you just collapse the entire thing. So who cares what's inside of it? We can just use initialize card rows everywhere else, and we don't have to think about what's inside of it. Now, I'm not going to do that because I don't like being like surprised because I forgot that I collapsed a whole bunch of logic, and I'm like, oh, but this is a very, this is a technique that a lot of people do use. I avoid it because I think it can be a sort of a crutch. It can lead to you writing too much code basically and using this to hide it, and then you're not aware that you wrote too much code basically. So I'm not going to do it, but that is an option. If you want to just literally forget about everything inside of here and only look at the file with a smaller number of things, you can do the same with this. You can collapse almost any block, basically any block of code. You can collapse multi-line objects like this. But, again, it's something I try to avoid doing. Anyway, the point is that we can forget about what's inside of here. And whenever we want to get a new set of rows, we just say const new rows or whatever equals initialize card rows. We run our function, it returns our rows, and we have them. And now everywhere else in the program, we don't have to wonder, we don't have to look at a big block of code and be like, what is all this doing? We know that it's doing initializing the card rows. That's what it's called. That's what it does. So let's console.log our new rows, and let's check that we have what we want so far. So I'll run this again. And okay, so it looks like we have the right shape. We have an array. It's got another array inside of it. It has this card object thing, and it actually has 7 of them. And then that array ends. We have our second array. This has 7 more of these card things in it. And we have a third array, and that also has 7 cards in it. So this is kind of like there must be a whole bunch of like extra information inside these cards that's, just from this deck library thing. And who cares what it is right now? I'm really just concerned that we have the right shape and that we have something in the place of each card that we're going to be able to use as a card. And we're going to be able to then manipulate these 3 rows of 7 cards and do our trick. So let me just look up what I'm doing next here. Okay. So this is all really nice. The shape is nice. We've got the right shape. But this here, it would be much nicer to just be able to see, 6 and then the club symbol instead of card, suit, rank, which doesn't even tell us which card it is. That's not extremely helpful as a human. It'll be usable as a program, sure, but we want to print the actual card. So let's figure out how we're going to, let's make another function. And rather than try to, remember what is the pieces of this card, let's figure it out once and then make a function that does this task that we need to do. And the task is to take one of these card objects that comes from our dex thing. And don't worry that this doesn't look like JavaScript code. This is like how JavaScript prints out an object thing that has a certain kind of name. And this is to do with it's just how the object is rendered as a string. And don't worry about it not looking like JavaScript. This is just its output. It's for some reason it's printed out looking like that. Don't worry about it. I don't know either. What we really just need to do though is take one of these objects. It's not actually this string. It's some kind of JavaScript object, and we need to turn that into the nicely rendered symbol, the number plus the suit. And once we figure out how to do this, let's just put that in a function and call it card to symbol. Now this does take an argument. Every time we call card to symbol, oh, Susan, you got an error. Yeah, paste it. Okay, here's actually I will cut. All right, I'm gonna paste all of this into the chat or the pasted code.
Okay, I'll double check that way.
Okay.
Thanks.
And it's possible, so I would guess it's one of 2 things, Susan. It's probably either this line is not exactly the same with the dot and everything, or
Okay.
you haven't run npm i from the right folder, maybe.
Maybe. I thought I did.
It might have been in a different folder. I don't know. Those are the only 2 things I could think of that would lead to what you're seeing. But try checking, especially line 2. And the reason I'm guessing line 2 is because when it says cannot read property standard deck of undefined, well, I'm thinking, where are we looking for something called standard deck? And it's actually right here. And if we say property standard deck, that means this dot, that's a property called standard deck. And it says can't read property standard deck of undefined. So it must think that dex is undefined. And that's only true if something's broken.
I had a curly braces around the decks on 2 because I thought you put them there, but maybe you just did it as an example.
Well, so the initial example was like this, but it did not have the dot dex at the end. It's got to be one or the other.
Oh.
Yeah.
All right.
Okay. And then, that's how I kind of read this error and try to figure it out is you look for, where am I trying to access a property called standard deck? It's right here. And so the property of, it must think this is undefined, basically. Yeah. Okay. So what did we do? We said, oh, we're going to define another function right after this first function. We'll call it card to symbol. This takes an argument. This will be called card. and it's going to take one of these objects, whatever the thing is that's printing out this nonsense, and we're going to return the nice string symbol. And then we can use this function wherever we need to turn one of those card things into a nice formatted card to print to the screen. So this is like just this is just what I found. So I looked this up in the documentation. The way you get clubs, you know, clubs, diamonds, spades, or hearts, or no, the way you get the number, or K or Q or J for Jack or A for ace, is a thing called card.rank. And see, rank is right here. And rank has another thing called short name. And you could find this if you were just exploring. You could actually find this by saying down here, I'll run in my terminal really quick, node, and I'll copy this whole thing, line 2. And just a really quick demo. You don't have to do this. This is going to be fast. We'll bring our dex thing right into our node terminal. I'll say dex.standardDec. Well, that's a class. Okay. Okay. So cannot be invoked without new. Okay. Well, it needs the new. So const dec equals new this. Dec dot shuffle all. Sure, why not? Dec dot draw one dot yeah, sure. Okay, actually, and now this prints out the whole structure of the whole object, because I guess node has it's small enough for it to say I'm going to print the whole thing. So you can see the structure of this card that we see in the other context is actually, it's an object which has, you know, these capital things are just kind of like it's the class name of the object. It's just, it's not exactly JavaScript. This isn't valid JavaScript, but it sort of looks like the object, and we can sort of figure out the structure from this. So if I do dec.draw1.rank.shortName, oh, it returns an array. So I need to grab the first, see this? It's actually an array of only one card. So I need the first item in that array, .rank.shortName. And that's going to be the symbol we need. That's good. And then the other one was going to be suit. Okay, so do another one, rank dot, or not rank, dot suit, dot name. Okay, and that gives us our name, our short name of the suit. And you notice I drew a new one each time I ran this. So that's why this is clubs and this is spades, and every time it's a different card, I guess. But this tells us the things we need. We need .suit.name, and we want .rank.shortName. And we can use those to render our card. So whoops, Control C. So in our function, we'll say card.rank.shortName, which is that one character. And then we'll concatenate that with the suit symbol from our dictionary, from our object here that we defined at the very beginning. And the key for this object is going to be card.suit.name. So spades will be used as the key right here. And the key that is spades is going to return, you know, if we find the element or the property of our object with the key that has spades, it's going to be the symbol for spades, and that's what we want. Now this would be the same thing as saying suit symbols.spades. Whoops. It's the same result in that case. But the trick here is that we need to get the value of one variable and use it as the key to this object. And you can't just do suit symbols dot card dot suit dot name, because JavaScript won't understand that in the way you want it to. You need to use these square brackets if your value that you're using to find as the key of this object is not a literal like string value that you're typing right after the dot. That part's a little confusing, but basically all you have to remember is that objects have the same way of looking up their properties as arrays do. And you need to use it if you want to use a variable to find the property you want. So this is the only way to get the suit symbol we want based on this card's suit's name, whichever card it is we passed in. So now we can immediately make one more function. And we can say, well, this function, okay, we have our way to get 3 card rows, and we have a way to turn a card thing that we get from our deck, one of these weird card things. We have a way to turn that from a object into a nice string. We can probably actually test it by saying console.log, or let's say const card symbol test equals new rows, the first row in the new rows, the first card in that row, because this is, again, 2 nested arrays. So the first row, first card in that row. And we'll pass this whole thing here. This is one of those card object things that we printed out. We'll pass this whole thing as an argument to card to symbol. So we'll just take the first card that we got from our rows. We'll pass it to this thing. Hopefully this converts it to a symbol. And we'll log this card symbol test, which should look like what we want it to look like a 6 and a club, or a K and a diamond character. So we'll save this and check it out. Whoops, I just ran node. So Control-C, Control-C. Node, or I'll press up 3 times. You can press up as many times, it'll go through all of your history, which I guess my history only has, it has the NPMI. But anyway, you can press up and down to sort of jump through the last commands that you can do it more than once, basically. But we need to run node card trick before .js. Boom, that's a good result. We got the format we want, number, and the suit. If anyone,
Our number that came back isn't supposed to match ours. It's supposed to be random, correct?
it's always random. So if you run it again, you get a different card.
Okay, I just wanted to make sure because I got a different card than you, so I wanted to double check if I was coding
Yes,
correct.
but you got a card, right? That's good.
Yeah, I got a Queen of Hearts.
Sweet. All right. If anyone did not get a card and wants to get it working, let me know. I will do the next function. I'll do another checkpoint in a couple of minutes. We're going to define one more function though. And this new function is going to take our entire rows, the whole structure we have, our array of arrays, and each element in the inner arrays is one of these cards. Latanya, what'd you get instead of the card symbol?
It just returned the same card, suit, rank. It didn't convert.
Did you pass this to the card to symbol function?
Mm-hmm. Card symbol test. Yep.
And
I didn't put the semicolon because you didn't, but the I'm
whoops.
guessing it's prettier, put it in anyway.
Yeah, it shouldn't really matter.
Okay.
Could you paste the contents of your card to symbol function?
Oh, wait a minute. Yours says console log card symbol test. Mine doesn't. It says new rows. Let me try that.
That's it.
Sorry.
That's what's going on. You're not yeah, this is like this value is the card thing. You pass it as an argument to card symbol, and the return value of this whole thing is then assigned.
Sorry, I can't hear you. You sound muffled. It may be just me, but
I hope it's not my microphone. How's it now? Well, now you're muted. I can't hear you.
It was muffled
You're
on
better.
our end, but you're better now.
Okay, I'll try to, let's see, hopefully that's good. I'll try not to cover up the microphone or anything. Yeah, the whole value that's returned from this function then is assigned to card symbol test, and that's what we're logging. So cool. Yeah, this is not easy to follow even when I'm clear to hear, right? It's we need every bit of clarity there can be. And we have, we're a little less than halfway done with the total lines of code in our card trick. So it should take us to a break nicely. Okay, so we want to make another function. This function is not going to render one card. It's going to take in the whole set of cards. So our array of 3 rows, and each row is another array of 7 cards. And we're going to take that whole thing and render out a nicely formatted 3 rows of cards that we can get from each individual card by passing them on to this function. So we'll call this new function render card rows. And we pass this card rows, which happens to be the same name right here, but it's going to be a different variable. You know, it'll be the same kind of thing. So that's why the name is the same, but we can use the name again because we defined card rows inside this function. So it's not going to get in the way of anything else in our program. So we can call it card rows here too. And we're going to use our array iteration method. This is the for each. Did we talk about the for each or did we only talk about the map?
I don't recall hearing about for each, so I'm
Okay.
pretty sure we didn't go over it.
Why don't we just use a map then? Because we've seen map. We probably mentioned it, but not as much as map. You could do it either way. Why don't we just do for each to give you a sample of what that looks like? For each is similar to map. It's like a function that you pass another function to. And in this function, so we can say function and I guess open our curly braces and then remember to close them right down here. This is the normal kind of way to indent. We're passing in this whole function expression here. And then inside our function, we can do something for each card row. Now, the way that for each works is that the function you pass it can have 2 arguments. It can have the actual thing that's in the array at that position, which will be our single card row. And the second argument can be the index that you're currently at. So if you call this on our card rows, which has 3 rows in it, it'll run this function 3 times. The first time this will be the first row, the inner array, that's the first row, and this will be 0 because we're at index 0 of the outer, the list of 3 rows. The second time this will be the second row, and this will be 1 because it's the index 1 of the second row. This will be the third row, and this will be 2 because it's index 2 is the third row. So knowing that, we can say that we will change each card in our row. Remember, this is 1 row. So this is 1 array of 7 cards. That's all. That's what this is. We can change that into an array of symbols using our map function. So we can say const card symbols equals card row, which remember is an array of those card things, and map that right to our card symbol function. Map that right through our card symbol function as is, because we don't need a different kind of we don't need to define this function inside here. We can use this. This takes our card row is an array of cards. It returns the thing we want to map it to, which is the string. So we just map with the function we've already defined. And if, we've seen this pattern less often, but just remember, this is the same as if I just took this whole thing and pasted it over into here. Now don't do that, but this is this, and this is a function. So we can pass it to our map function. Now we'll use the other, the way that we've used before to join together a whole array of strings into one long string. And that's the join function, which is another thing we can call on an array, just like map. So we'll say const card row string equals card symbols and join with, let's do a tab character. So you could do a space here if you prefer, but I'm going to do a \t, which is a tab character. And then we can say console.log right in here. This function will have a side effect. This will log right to the console. And I'll log a string that kind of prints out the row that we're on and then the whole list of cars. So this is row. I have backticks here, the character next to the 1 key, which will let us do this fancy technique of $, curly brace, and they turn blue. And then you can put a variable or something right in here. And row 1, we can get the number 1 by saying index 0 plus 1. So this will be 1, 2, and then 3, because the indexes are 0, 2, and 1. And this is one of the annoying parts of computer programming that will be the, you will not like this all the time, that arrays are starting at 0 and numbers that people understand start at 1. So there's a whole lot of this +1 nonsense that you'll see just because of that. That's why it's +1. Because we wanted to say row 1, row 2, row 3, instead of row 0, row 1, row 2. Colon, let's do space, and then another $, open curly brace, and we'll just drop our card row string in the middle there. And that with a semicolon. And now let's delete our this thing. We don't need to do this test. Let's try rendering our card rows right away. Render card rows, pass it new rows, and see what we get. Okay, if I type this right, it should look like a nice list of 3 rows of cards. Here we go. Okay, now we're getting somewhere. This is starting to look kind of like our card trick. This is how we lay them out on the table. And now all we need to do is manipulate the cards, move them around, and ask the user to tell which row it's in, and do the logic that we need for the trick. So the harder part of it, probably, but we are, I think we are more than half done. Okay, I'm going to paste all of this into the pasted code. Card trick checkpoint 2. Whoops.
I have a question. I had this problem when I was doing homework too. I get like a string when I type the $ and the curly brackets. It doesn't recognize, it doesn't turn blue.
Okay, are you sure you have backticks instead of single quotes?
Oh, okay.
Yeah.
That's probably it. Thank you.
Yeah, the single quotes will not let you, see, watch, if I replace these with single quotes, it will not understand this $ thing, and it will just print exactly what you typed here, rather than substituting in the variables you need. So these cannot be single quotes, they have to be backtick which is the thing next to the 1.
Got it. Thank you.
Yeah, Alina, it's node card trick before .js with a lowercase n, but yeah, otherwise. Okay. Now here's another piece. Mel, the backtick it means a similar thing to the single quote character. It means a string. I mean, it's another kind of string, and it's a newer kind. This is not present in like old browsers, JavaScript. They wouldn't understand this backtick. But it's a newer kind of string, and it has 2 properties that other strings don't. So if I did const my string equals, whoops, string, and I did single quotes, I could do blah, blah, but if I put a space, an enter, a new line in between them, JavaScript doesn't like that. It says you can't put a random new line in the middle of your string. You could do a \n, which, see how it's a little yellow, that will print a new line in the string, but you can't just type out stuff like this. The backtick lets you do that. So if I wrap this in backticks, it's fine. It's like paste whatever you want here. It'll be just a big long string. And the second thing you can do with the backtick is that $sign thing to substitute variables. And it will take this whole thing and replace it with the value that's inside the curly braces. So backtick is really just like a kind of quote. It's just a third kind of quote that they added because they're like, man, it would be really nice to be able to have a full multi-line string and be able to substitute this stuff, string interpolation, it's called. So that's what it means. It's the same as a quote. It's just more nicer. And you can use it for other stuff. I could just prefer backticks everywhere. If you want to just always use the backticks. I think you could even use it here. Why not? And here. Okay, I'm not going to keep doing that. I'm going to go back to this way. Generally, I don't use it unless I'm intending to do one of those 2 things, substitute or have a multi-line string. But yeah, otherwise, you know, you could use it for pretty much every string if you wanted. Yeah. Okay. Here's another piece. Hopefully that makes sense. If it doesn't, let me know. You know, ping me on Slack, whatever. Here's another piece we can break off of our program. One thing we needed to do, and do it several times, if you remember from when I demonstrated it, we are asking the person which row the card is in, getting their answer, and then our program is going to have to turn their answer, which will be a 1, 2, or 3, into the array index, a 0, 1, or 2 at some point. We're going to have to subtract 1 probably back from what, if they say 2, we're going to want 1 because we're working with the arrays here. So we can do all of that. We can wrap up all of that behavior and say, let's just make a thing that helps us prompt the user for a row index and turns their answer into a row index. We'll call this function prompt for row index. And we're going to say row number equals prompt. And we'll prompt the user by saying which, sorry, this is prompt sync is what I called it. We're going to prompt the user by saying which row is your card in. And put a space after it because that's a nice, it's nice to have a little space there. Okay. Now we're going to turn that number, so the user's going to type something in at the prompt. JavaScript is going to assume everything that they type in this prompt is a string. It doesn't matter if it's the number 1, it's still going to be the string that has the number 1 in it. So we're going to need to turn that string that they type into a number. And we're going to say row number equals parse int row number. Oh, and I didn't declare this. Whoops. It would probably error here if I left the let out. Let's check. Let's make sure that it errors. So we can initialize, sure, whatever. That's fine. But I'm going to say const row test equals prompt for row index. And then we'll log row test. Which row is your card in? 7. Undefined. Well, we're not returning. And well, that's not great because we've implicitly created a global variable here. I thought that I'm pretty sure React will prevent you from doing this, but Node doesn't care. You actually have to do a magic thing we will mention today called use strict. Might not, yes, it errors. Row number is not defined. So there's this magic thing you can put at the top of a function or the top of your module, which honestly, I think we might as well just do. It's just the string use strict and then a semicolon. And this will tighten up the JavaScript interpreter to say, don't just silently make a variable called row number if we forget the let, because that's a global variable now. That's the scope of that that's a dangerous thing to do. So just error instead, and then we'll fix it. So we need the let in order for it to run. Now that we've put that, you don't need to worry about that when we get into React. Yeah, it's just this expression, which is just a string, use strict and a semicolon at the top of the file. Or you can put it just in one function at the start of the function, but we might as well just have it everywhere. So we'll put it up there. And again, once we get into making a React application, you don't need to worry about this. The default setup will just handle this for you. And that's I think that's in the slides today. Okay. So we can, yeah, we initialize it correctly. And we say, which row is your card in? And it echoes back 6. Well, now we only have 3 rows. And by the way, I can also say blah, and it's going to say not a number, because it tries to parse whatever we do into an integer. And blah is not a number, so it becomes this value not a number, which is a special weird JavaScript number thing. If you watch that Gary Bernhardt talk called WAT, W-A-T, I think it's in the class materials. It's all kinds of crazy stuff where stuff becomes not a number. And this is one case where you try to parse, it's not a number, and it's not going to work. So let's make this a little more durable. Here's what we're going to do. We're going to first declare row number and just leave it here so that we've declared it at the top. It doesn't have anything in it yet. And we're going to loop forever, if necessary, until we get a good row number. We're just going to keep trying until we get a good row number. And we know we have a good row number if the row number is greater than or equal to 1, and the row number is less than or equal to 3. Because it needs to be 1, 2, or 3, and it needs to be a number. Not a number won't be either of these, I think. So we will loop actually when this here, all of this is not true, because until these are both true, we know we don't have a good row number. So let's wrap the whole thing in another set of parentheses here. And then in between these two parentheses, we'll put an exclamation to be not this. So if row number is not both of these, we're just going to keep looping until it is. And we're going to say this code, we're just going to move it into our loop. And we'll say row number equals this. And then once we run this, if I say blah, it's just going to ask again. It's not going to accept it. It's not going to accept 7. It's not going to accept 6, 0, -5. It will accept 1. And then we're done. And now we can return it and we can proceed. So this we know is a good row index. So that's a nice way to just make sure that, you know, the user is providing a valid answer. If we want to tell the user to try again, we can do that in a bit. I just want to make sure we don't take too long with this whole example. So yeah. Okay, we have one more pretty big doozy of a function, and then we can put together all of our functions and do the entire trick. We have one more piece to define. Does anybody know what that piece is? Like big chunk of this program, not the whole thing, not the start to finish of the trick, but like there's one more big piece that's really missing from that we haven't defined yet. We have getting some rows, we have turning cards into the symbol, rendering all the rows, we have asking the user for which index it is in. What's left?
Randomize.
That was like a sound effect from an 80s, from the Talking Heads or something. That was pretty cool. Okay. Yes, I think Carolyn, you're Mel. Yeah, we need to tell them the card at the end, but there's a big piece that we're missing before that, which is that once they tell us which row it is, we need to redeal the cards. We need to grab them, put the thing in the middle of the other two piles, and then reshuffle them into 3 new rows. And that's gonna get fun. We're gonna use some fancy JavaScript stuff, some of which we have seen. And we're gonna call this function redeal card rows. Now this will take a card rows, and it's going to take another argument too. And by the way, I'm reading this off. I didn't memorize all this. I am reading this off of the finished one. So yeah, I'm not like, nobody programs like this in the real world. Just in case you're like, how the heck are you typing all this? Nobody types like this. This is a contrived example. So we're going to need a second argument. And I already know that because I have the finished program in front of me. The second argument is the row index that the person selected. So we said, which row is your card in? They give us a number. We need to give this function all of the current rows plus the number they picked, because remember, that pile of cards has to go in between the other 2 piles of cards before we redeal them. So the second argument will be selected row index. And this function gets really fun. We're going to say first const selected row. And if the row was the last row, we could do card rows.pop, and that would give us the last row. If it was the first row, we could do unshift or shift. I forget which one. I always get those two confused. But we don't necessarily know which end it's on. It could be in the middle too. And then we couldn't do pop or unshift to grab 1 row out of our 3 rows. We actually need to use an array method called splice. And I think, Brandy, this is the one that we use to pull the color, the color that was selected out of the list of colors. This method allows you to grab one item out of an array, return that item, and then change the array so that it no longer has that item in it. And this is a riskier kind of method because it modifies the array that you pass it. So it modifies the array that it's called on. It's like pop, or it's like something that actually changes the array. So it mutates the array, is what it's called, but in a way that we really want. If the person selected, oh, I have a bug here. They're gonna pick 1 through 3. We need to turn this into an index 0 through 2. So I gotta subtract 1 from that. But once we've called this, we have an index into our array of card rows, and we need to grab the actual row at that position, pull it out of our array, and reorganize them. So we can use the splice method, which will say the index to start cutting out of our array. And that's the one we selected. If you selected 0, it's going to cut out the first object. If you selected 1, it's going to cut out the middle object. And if you selected 2, I mean, obviously the index was 2, it's going to cut the last object out. So it's sort of like pop, but you can pull any number of things from the middle or either end even. Yes. Okay. Here, let me just, yeah.
I have a question too, Gus. This is Latonia. Did we define our row number?
Let row number.
Right, I have that. I received an error message saying it is not defined. I was just wondering if I missed something.
It's inside prompt for row index.
Mm-hmm.
Which line are you getting the error at?
I'm not sure.
Okay. Let
That's
me,
okay. That's okay. I can look at the code and try to figure
yeah,
it out.
and let me get to the next checkpoint. I'll paste this. Yeah, Alina, I'll paste this in 1 second. As soon as we get this splice thing. The second argument to splice is it's called delete. It says delete count right here. So index to start at, delete count. Well, it's always 1. We're just pulling out 1 row, the row that they picked. So we're going to grab 1 thing from this array. And this splice, if you look at the documentation for the splice method, array.prototype.splice, in that whole documentation thing, this returns another array with the items you cut out of your original array. And we always get 1 item out of there. So we have to grab it out of this array that splice returns. And Brandy, this was the same as like getting the color. Once we spliced one of the colors, we needed to do the 0 to get that 1 color out. And so here's our selected row. This has pulled it out of our card rows, and it's now saved in this selected row variable. And then we still have our card rows, which should now only have 2 items in it because we've yanked one of the rows out of this. So I'm just gonna save right here, and this doesn't really do anything different because we're still in the middle of writing it, but we'll say card trick checkpoint 3. Whoops. I had them nicely formatted, so it was all in the same comment. Okay, so that's where we are right now, card trick checkpoint 3. And we are in the middle of this redeal card rows function. We have spliced out the selected row, the one that the person said their card was in. The splice returns the array of spliced out things. It only has 1 object in it because we're only splicing 1 thing. So we grab that with the index 0 right away. And that's our selected row. Now, we can make a brand new pile of cards, and you saw what I was doing. I took the pile that the person said their card was in, and put it in between the other two rows. And so we need to do the same thing here with our array of rows. We need to construct kind of a new row, or sorry, a new array of rows where this row is in between the other two rows. And a nice way to do this in JavaScript, we can use that spread operator we talked about yesterday. So if I do const pile of cards equals, this will be a brand new array. It'll also have 3 rows in it. The first row is going to be, sorry, no, this won't. This will just be one flat array that has all 21 of our cards in it, because we need to reshuffle all of, after we put it in the middle, we need to redeal into 3 new rows. So the easiest way to do that is to just say flatten everything out into one big array of 21 cards. And we can do that with our spread operator. Sorry, I got ahead of my, I didn't understand what this code was doing for a couple of seconds. We can take the 2 rows that are left in here and flatten them out into our array by doing the ... card rows 0. That's the first row that's left in our array. And ... card rows 1. That's the other row that's left in our array. And in between them, we can flatten out our selected row. So this will always grab the thing you select, pull it out of your array. You're left with 2 items in your card rows array. Those 2 go here, and this one goes here. And because we're spreading them, it's not nested, it's not an array of 3 arrays anymore. It's an array of 7 cards plus 7 cards plus 7 cards, all flattened right out into this one big pile of cards. And from here, it's not that hard to deal them into 3 new piles. We can do this with a for loop and a modulo operator. So I'm not gonna, we don't have enough time for me to do this in the Socratic method, because it is rather tricky, but here's how you would do that. We're gonna make empty arrays to put our new cards into. So we'll say const, whoops, wrong thing. We'll say const new rows. This is going to be our brand new 3 rows with the same cards, but redealed into these 3 new rows. It's going to be an array with 1 empty array, 2 empty arrays, 3 empty arrays. Here's our empty rows and our whole thing ready to go with no cards in it yet. Now we need to move the cards, the 21 cards in this big pile of cards, into this one, then 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 this one, just like we did on the table. And we can do this with a for loop. We can say for let I equal 0. We have 21 cards, so we need to loop 21 times. I is less than 21. And I plus plus. And in this, we need to turn I into the row it's going into. So I needs to turn from 0 into 0, 1 into 1, 2 into 2, 3 into 0, 4 into 1, 5 into 2, 6 into 0, 7 into 1, 8 into 2, 9 into 0. This is the modulo operator. This is exactly what modulo 3 will do. It will turn 0 into 0, 1, 2, 3, 4, 5, 6, 7, 8. It will loop around, and every time it's divisible by 3, it will go back to 0. So we can say new rows. And the way we get this index of which one, this one 0, 1, or 2, is by doing I modulo 3. That is going to be hard to understand. It may be the hardest part of this whole program to understand. Maybe that or some of the mapping stuff. But when I is 3, I modulo 3 is back to 0. And we get back to this pile. And it will proceed all the way up to through our 21 cards and deal them effectively into our 3 rows. Now that we know we have the right row, new rows 0 is this thing. New rows 1 is this thing. We're in the right row, so we need to just push our card that is at this position in our big pile into the row. So that's going to be pile of cards I. And that's it. We go through all 21 cards, we find the right row with the modulo operator, and we push the card that's at this position into the right row. We could also do this with a pile of cards dot for each to make it consistent, and it would look something like this. Card I, you could do the arrow function if you want, new rows, I modulo 3. Basically the same thing, but instead of pile of cards I, we can just do card here. So the nice thing that this gets you is that you get the card immediately. You don't have to grab it like this. But I will comment out this one and just leave it here in case you'd like to see how you do the same thing with the for each. Yeah. And the same is true, of course, of the for loop that we have. Where's the other for loop? Yeah, oh, the for each here. We could do this with a for loop, so to go the other way. It's either or, really. And you know, I'm just this has a demonstration of both kinds of loops. Okay. And then the last thing to do, the only last thing to do that this function needs to do is return our new array of 3 rows, which each have 7 cards now, because we've pushed 7 of these into each of these little arrays. So this one is probably the trickiest function to understand, definitely. I mean, this is, you know, doing the actual shuffling, reshuffling operation, and this is how you would represent what we did with the cards as code. So, you know, over the next couple of weeks, if you want a nice mental puzzle, watch the video of me doing the shuffling with the cards and try to really understand what each of these pieces are doing that is the same kind of operation, but, you know, this time on concepts, on computer numbers instead of real cards. It is very similar, you know, the structure of this or the logic of this is very similar to what you do with the cards. But that's how complicated it is to just say, put one pile between 2 other piles and redeal them. This is about as simple as you can make it to do that. Okay, so that's the last big giant piece, which is the most confusing perhaps. But with that, we are ready to do our entire trick, start to finish. So we can now, our last function will define. We'll get rid of all this test stuff. Actually, let me do one more checkpoint. I'll copy this. Okay, so that's checkpoint 4. We have our redeal. The only last thing to do is our whole trick. So we can make a function do the trick. And it doesn't have to be in a function this time because it could just be the rest of the program, sure. But we might as well just make, if in case you ever wanted a program that does this trick more than once, it's nice to have this in a function too. So first, we initialize, we get our initial cards. So let card rows equals initialize card rows. And again, we can use this name again and again because each time it's in a different function, it's in a different scope. It's in this function. And so they're not going to interfere with each other. We can pass, this into another function. And in that function, whatever variables we define will not collide with it. So we initialize our card rows first. We tell the user console.log, just pick a card and remember it. Then we do this shuffling thing 3 times, right? I think, oh wait, we do it at least twice. And then from the 3rd time onward, the next time they say that it's in the middle row, it's the middle card of the middle row and we can pick the right card. So we're gonna do the same thing twice by doing a very simple for loop. So we'll say for let I equals 0, I is less than 2, I plus plus. This will only loop twice. This will just go twice. And then we'll say render the card rows. So show the cards to the user in the order that they're currently in. We're going to ask the user to tell us which row it's in. And we already have a function to do that. So we'll say const selected row index equals prompt for row index. We've already written this. So all we need to do is call this, and we're going to get out of that the row index that they picked, or the row index corresponding to the number that they picked, again, with that plus minus 1 thing. And then all we need to do is redeal according to what they selected. So card rows will now be equal to redeal card rows, pass in the current card rows, and the selected row index. And that's our crazy redeal function, which does all the the modulo and the dealing out into 3 new rows. So we do that whole thing twice. And let's just try it. Do the trick. See how it goes. Yeah, it's broken. Cannot read property for each of undefined. Card rows dot for each. Card trick before.js 29. So we're all the way up on line 29. And it's saying cannot read for each of undefined. So it must think this is undefined. And why would it be undefined? We have render card rows, and I'm not passing it anything. That's why it's undefined. We need to pass it card rows. Okay, let's try this again. Yeah, line 69. I was calling render card rows, thinking, oh, we'll just render them, but you actually have to pass it the cards to render. Okay, pick a card and remember it. Which row is your card in? Who cares? Twice and it's done. And it doesn't do anything else. Now, let's okay. We do this until the card is in the middle row. So at least one more time, and until the user has not selected the middle row, which is index number 1. So we'll say let selected row, and that will be undefined right for now. And we're going to loop basically forever. It really should never be more than 2 more times. But if the user is kind of forgetting which card it is and they just keep putting in random numbers, the trick will probably never end because it will just keep shuffling and it'll be like, well, it's never in number 2, or it'll just pick the wrong card. So, we'll just say while they haven't yet picked row number, the middle row, which is index 1. So selected row is not equal to 1. While that's true, we just do the same thing here. So I'm going to copy all of this, just paste it right into here. And oh, it's called selected row here. So I guess, yeah, I need to call it, whoops. I need to call this selected row or this selected row index. And again, we can reuse this name. Wait a minute. Yeah. We can reuse this name because it was defined up here as a const. When we go through this for loop, it's defined inside the for loop also, but that's a block. That's its own block scope. And so we can still have the same name down here. I think in my final example, I called this selected row, but you can use the same name if you want because you're no longer in the same block where this one was defined. I'll just call it selected row though, just like before, just to not be as confusing. It's still pretty confusing, but so while that selected row is not one, we're gonna assign to this thing that's defined outside of our block so that we can check it the next time. And until the user has picked the middle row, and that's index 1, we're just gonna loop this forever. But once they have, we don't need to do this anymore. We know which card it is. It is the middle card of the middle row. So we can say const user card equals card rows. The first index is the middle row, 0, 1, and 2. And then the middle of the row itself, like the middle card of the middle row, is going to be in position 3 because it's 0, 1, 2, 3, 4, 5, 6. It's 7 total cards. Index starts at 0. So it's going to be index number 3. And we know that's the card they picked if they answered everything correctly. So all we have left to do is log it. Console.log. These are backticks here. Your card is : and we will turn their card. Remember, these are all those weird card objects. So we got to turn it into the symbol. So it's card to symbol. And we pass it the card that's in that position, user card. And that's it. That's the whole trick. Pick a card and remember it. If I pick, let's say 5 of spades, it'll say, which row is your card in? It's in 1, so I answer 1. Which row is your card in? Number 2, so I answer 2. It's in 3. And it's in the middle position, so this time it's going to get it. I'll say 2. Your card is the 5 of spades. And yeah, so you should be able to pick whichever card you want and answer the prompts, and it will work. Now, the last thing we do, we'll add this tomorrow. I think we don't have time to do it today, but it's kind of a giveaway. If I pick like 6 of spades, it's 3, and then where? 3 again, and then 2. It's kind of a giveaway that it always ends up right here in the middle of the array of cards, or the grid of cards here. So what we can do to fix that is make it so that it always renders the cards in a shuffled order. So it displays them in an order that is not what it is keeping track of them internally. And because you're only answering the row, that's the only information it needs. It can just shuffle them each row each time. And that will confound the audience because they won't see that, oh, it always ends up in the middle. It could be anywhere in this row by the time it gets the answer. So anyway, that's the whole thing. I know that's a ton of code. I'm going to post this final week 7, day 2 checkpoint. Yeah, it might take a little bit to sort of, I know I kind of rushed over some of the explanations, but there's each of these are some of the things we have seen. And, you know, if you really try for a long time, maybe you'll really get how each part of this program works. And this is sort of, you know, again, I don't expect everybody to have understood all of this. It's, you know, we've had our first exposure to things like the spread operator and, you know, the modulo operator. And this is a neat way to show how they can be used to do something other than just the math problem. But it's still, you know, it's still going to take a bit of sort of banging your head against this to really get it. But that's fine. If you want to go through any part of this, if there's any one part of this trick you really don't get, please let me know on Slack or ask the whole class. We can go over a piece in class. And I think tomorrow we'll add a thing that shuffles up a row so that it makes it a little less obvious how it works to the audience. Now you can see the code so you know how it works. Yes. Anyway, all right. Card trick final week 7 day 2 checkpoint. Okay.
So should I be running something in my terminal besides node card trick before.js? Because it was working originally, like at the last checkpoint. And then I don't know, now it just doesn't even pop up the question. I don't know, maybe I messed up my code. I'll go double check with yours.
Are you running the function do the trick at the very end?
Oh no, I didn't add that part. That'd probably be why. Sorry.
So you defined all these functions and then you didn't actually run anything. So that's why. Yes.
Makes sense.
Susan, there are no dumb questions. You can hover, you can bring your mouse up to the top of the screen and this stuff should go bloop and appear like this. And then you can press the green button to bring it back. Yeah. Yep. Okay, I think it's break time and then we're gonna go into this lecture, which is my least favorite lecture. So get excited. It's the worst stuff. And the reason I don't like this stuff is because I never use it and I think it's silly and dumb and I have to explain it because it's part of JavaScript. So, you know, I disagree with some people about some of it, but largely like you're not going to need all of this for React and your actual capstone. It's a lot of it. You just need exposure to some of it. So we just need to tolerate this today and a bit tomorrow and we should be good. Okay, break. Let's come back at 7:40 and then the last hour will be slides. And yeah, I think I'm gonna leave everything as is with my changes here, even in GitHub Desktop with these changes, just because I want to pick this up tomorrow. I'm not going to check them in or anything, but we'll keep pasting the latest code into that pasted code channel, just so that we have some checkpoints that you can go off of, even if you discard your changes or need to change or want to mess with this in between. So yeah, all right, 7:40. On some lobby music. Uh-oh. Susan, you might have to press Control-C. To get.
Well, okay, maybe I might have a mistake though.
Yeah, but you probably have to press Control-C to get it to end the once, and then I would check very carefully your while, whether that matches. And whether you have the row number -1 here, do you want to see an interesting trick for how to, if you want to keep the code you're typing and find the differences between your code and what I've pasted, the checkpoint code, there's like an easy way to do this.
Yes, tell me without making my brain hurt. I'm going back and forth and it's so difficult.
Okay, so here's what you can do. I'll make one little change. This is user car. Uh-oh, that's wrong.
Yeah.
And I will make a brand new file in the same folder, new file, pasted thing. Whoops, I should rename that, make it pasted thing.js. So at least it knows it's JavaScript. And then I will go to Slack. I'm going to grab the last checkpoint here, which should be almost the exact same thing.
Right.
Come on, I didn't want to open a dictionary. That's
That
not what I,
happens to me all the time.
okay. Copy all of this out of Slack, go back to VS Code, paste it into pasted thing.js.
Mhm.
Why is there no spaces between the lines now? Oh, really? Slack doesn't even do that? This is terrible. So you literally, you paste it and you get no lines between anything? Oh my God, that's awful. Well, I'm gonna space it out myself then. That's terrible. That ruins the entire pasted code thing. Nobody told me about this? Why wouldn't you speak up? This is awful.
We don't know what we're looking at.
Okay, well, anyway, now it's going to be totally different than what you have. But the way that you can check, you put the two things you want to compare in two different files in like VS Code over here. So we have pasted thing and we have card trick before.
Mm-hmm.
You can do control, select for compare,
Ooh.
control the other thing, compare with selected. And
Oh.
put them side by side, it will show you additions. So obviously this one has a bunch of new rows and it's pointing out exactly here that I have deleted the D in card and actually deleted a new line. So if I make a new line, yeah, it shows me exactly what was deleted from this one to this one.
Oh.
It's very similar to a git, like, you know, the git commit diff. If you go to like,
No, I actually don't know how to do that.
well, it's showing you the same thing. It's called a diff. It's basically the things that have been added in your repository are green. The things that have been removed are red. But this is a different style where it all kind of does it on one line. And because I'm only usually adding code to this repository, it's all green stuff usually. But it's the same kind of thing in general. It's just going to stack the red and the green on top of each other. This way, it shows them side by side, which is actually arguably much nicer for trying to find the differences between them.
Yeah.
So I can bring them back into exact alignment by just adding my lines wherever they're missing.
Okay, I'm going to try that.
Anyway, that's a cool trick. It's a nice way to use the tool to, yeah, I think it's also kind of cheating, but I understand why you'd want to do that rather than just paste over it. Because you can see exactly where you actually had a difference or where actually you had a typo, you know?
Yeah,
Yeah.
no, definitely, especially in this scenario.
Yep. Yeah. Yeah, this writing a whole program in a hurry with concepts that we've barely had time to even start to understand. Yep.
All right, thank you.
Yep. And I think, yeah, when you're done with that, you probably want to close that because I don't even know, like it's, come on, close it. Yeah. Because I don't even know like what happens when you save it. Does it save both or maybe it saves both? I don't know. Anyway. All right, I'm gonna go to the bathroom. Be right back. Play some Oh, hey, Jason, how you doing?
Excuse me, Gus.
Yes.
This is Latonia. So I was just going through my code trying to figure out what is going on. I get to pick a card and then it keeps saying this row number is not defined. And I swear it is. It's in the while function that we made.
Yeah, I think it might be because of the, it's a little confusing, but like you have let selected row here, and then everywhere here and here and here, they're all selected row. There's 3 places.
Oh, you know what? I still have row number.
Oh,
Wait, is
select,
that the right place? That's not the one I'm looking at.
which line are you at?
I'm at 30. Well, on mine is 36, 37. Function prompt for row index.
Oh, okay. Row numbers, this and this. This, there are. Ah,
Hmm.
sorry, a drone ant or a queen ant or some giant ant just walked out of my foot. That was weird.
Sorry.
Yeah, so you have 5 or 6, you have all these row numbers, 1, 2, 3, 4,
1,
5.
2, 3, 4, 5, 6. Yeah, I have 7 total
And you
with
have
the -1.
you have a let inside the function.
Let is inside the function. Then there's the while with the not.
And your error is, could you paste this whole function and your error?
Yep.
Okay. And we're gonna get started on the slides, but I should be able to just glance and be so good at debugging that I'll just be able to find your bug immediately. Not really, but you know, I'm pretty good at it. Yeah. Anyway. Okay. Let's get started with the slides because we're gonna run out of time on these. It's probably a good thing. These are my least favorite subjects, and it's a little controversial maybe, but it's kind of partly because this is a lot of stuff. Not only is it very confusing stuff, but it's stuff that like you're not going to use that much when you're using React to build an application. And it's here because we need exposure to all this stuff. And it's going to be very confusing. But a couple of the things are going to be useful. I will call them out. The things that I think are like, you know, so let's get started. Latonia, whenever you have that stuff to paste, just throw it in Slack or in the chat or whatever. So, oh, you got it. You've misspelled row number in the while loop. In the while loop, you forgot the B.
Thank you. I'm so sorry.
That was like 2.5 seconds.
Yes, it was.
Yeah. What's up with that code, Susan? While select a row is not equal to 1, in your card rows, prompt for row index.
I mean, you don't have to do it now. You can look later. I did the thing you said. I compared it and it looked right. So I don't know.
You're definitely picking row number 2. At the end of the trick, at some point you're picking row 2.
Me?
Yeah.
In the game? Yeah. I mean, I
Okay.
picked the card.
All right, let's look at this later. I'm stumped. I can't figure it out.
Okay, yeah, later.
All right. Okay. Object-oriented object programming, function application, hoisting the this object. There's a thing in JavaScript called the word this. This is my least favorite day of lecture. Okay. Object-oriented programming. Who's heard of this? I guess just ping the chat if you've heard of this. It's kind of one of those words that was thrown around a lot for a while. It's not so popular anymore. The popular thing these days is functional programming, which is closer to kind of like what React does. Functional programming, it's like passing functions to functions and things like that. But object-oriented is like the, C++. Anyway, it's programming that organizes your code using objects. In our card trick, we kind of organized the code using just functions. We didn't really have a whole lot of big objects that was like card object and this object. But if you're organizing your program around objects, it's called object-oriented programming. Now, the thing about the objects is that they have both data and behavior. This is not in the slide, but the methods in an object, in a JavaScript object, plus the properties, the data in the object, together, all of that together grouped into one thing that's called an object, that's what really makes it object-oriented. You're putting together the behaviors that data should follow with the data itself. React is closer to like this functional programming style lately. The latest kind of like recommendations are closer to maybe functional programming. You're going to have to be familiar with this object-oriented approach. At some point in your career, you might encounter C++ or some other language. You might encounter programs that are written in this style. The core idea in object-oriented programming is to divide programs into smaller pieces and make each piece responsible for managing its own state. That is the key part. It's not like with functions, we talk about you don't want the function to have side effects. You don't want the function to alter data outside of the function itself. Objects, they own their own data. They have data plus functions. They keep some bit of data, their own state, it's called, and they run functions to operate on that. And it's all grouped together. More traditional kinds of object-oriented programming are in other languages, not JavaScript. C++, Java, not JavaScript, but just Java. C#, Python. These are traditionally, largely object-oriented languages. You usually talk about things like classes, classes of objects, and inheriting from one class of objects to another. JavaScript has like its own word called class, but they're kind of faking this classes pattern. And these are newer. They're just a newer way of kind of pretending to have the same exact keywords and behaviors. And JavaScript has something called prototypal inheritance, and that's related to that array.prototype.splice or array.prototype. That you see in that documentation. inheritance is based in JavaScript on something called a prototype. And it follows a certain behavior that makes it different than other object-oriented programming. And the whole thing might as well just not be used, according to me. So I don't really like JavaScript's object-oriented features. They can be useful. They're used in many places. I avoid them as much as possible. But you're going to encounter them, so you got to know about them. Here's like what inheritance is, the traditional view of inheritance. In like C++ or in C# or in another language that has, you know, classes everywhere, class this, class that. This is like a traditional thing people will do in like a programming 101 or something, where you make this conceptual model of different things that your program can work with. And the basic idea is that you make these, I haven't even defined class properly. A class is basically a factory for creating objects. It's a template, it's a pattern that gives you objects of a certain pattern. So in this diagram, animal is a class, duck is a class, fish is a class, zebra. And when you make new animals, new this, new that, that's where the new keyword comes in JavaScript. You are making objects that follow the pattern that's defined in your class. That's really the whole concept there. I'm going to rename this, whoops. I'm going to rename this whole thing classes and inheritance, because, yeah. So in this example, this is like a very just basic example. You would have a class called animal. An animal is a pattern. The objects, when you do new animal, you're going to get an object that follows this pattern that's defined by your class. This object would have properties, age and gender, because I guess every animal has an age and gender, I don't know. And then animals have methods, they can also have behavior. The point is that these are grouped together under this concept of animal. It has data and it has methods. This is true or false, whether the animal is a mammal. I don't know why mammal is not just a Boolean here, but it's up to you, basically. And then I guess animals mate with other animals, sure. So behaviors, data, this pattern is used to create objects which all follow this pattern and can all kind of be predictably substituted for one another. So anywhere that you would do something with an animal, you can do something with any animal, this one or that one. They're all going to follow this pattern and have this, what's called an interface. So inheritance is basically when you have another class here, like duck or fish or zebra, and this is another pattern for another kind of object. This is another class, but this arrow would mean duck inherits from animal, which means duck defines its own things. It has a property called beak color, which every animal does not have because it's not a duck, or it's not even a bird necessarily. Duck has this, but it also has an age and gender, because this means it inherits from animal. And in a language like, you know, C, we'll say C#. C# inheritance. W3 schools. So here, this is how you would show this in C#. You would say, here's your class, your top class vehicle, which has a brand. I guess every vehicle has a brand. Very silly. This whole thing is very silly. I don't like it. And by the way, I'm going to get in trouble probably for talking like this for bad mouthing object-oriented programming, but it's too bad. I don't like it. This is a vehicle. It has a brand. It has a method called honk. That doesn't make any. This is a terrible. I'm out of here. A vehicle. Every vehicle doesn't honk. That's silly. A bicycle doesn't honk. Okay. this is part of the problem with object-oriented, is that the world doesn't fit into neat taxonomies like this. You can't, and it always falls apart. It just is. Here, maybe Microsoft. Let's go right to the source. Anyway, all I wanted to say is that you have one class, you want a class to inherit from it. In C#, it looks kind of like this. And what that'll mean is it will automatically, anything created with this template, this class, it will automatically grab, it will inherit whatever the parent class had. I don't know what this is doing in here, but that's what inheritance looks like in another language. The colon, C inherits from A. In the diagram, it's the arrow. So duck inherits from animal, fish also inherits from animal, zebra also inherits from animal. So if you said new zebra, you would automatically be able to say that object, my zebra equals new zebra, let's say. And you would automatically be able to say my zebra.age, and it would have a property called age, because the pattern it's based on, the class zebra, has inherited from this pattern, which is the animal pattern. Zebra, and you describe this by saying a zebra basically is a kind of animal. It has all the things that animals have, but it's a special kind which has its own thing. And yeah, there is a lot of theory about this. Why aren't animals arrows pointing from animal to duck, fish, and zebra? It's because the meaning of the arrow, it's just kind of an abstract conceptual thing. The direction of the arrow, it says, is like, it's like if you had the word is a on every arrow, and you follow the arrow and you say, the thing at the beginning is a thing at the end. Duck is an animal. Fish
Okay,
is an animal.
yeah. I'm just thinking you inherit from the animal. So
Yeah, it's
kind of
not.
like family tree-ish wise, but okay, I hear what you're saying. It's, I know why you don't like this stuff, so thank you.
It's all kind of loaded words. There is a principle called, what is it called? Let me see. Liskov. Is it Liskov substitution? Yeah. So the objects of a superclass shall be replaceable with objects of its subclasses without breaking the application. This is one benefit you can get from inheritance. You can define your application so that you have a function that expects anything that's an animal. And then the Liskov substitution principle tells you you should be able to pass a zebra instead of an animal, because a zebra is an animal. And you should always be able to substitute any subclass that inherits from this class with this class. So that's the, what people talk about, object-oriented classes, inheritance. I don't like the whole thing. Inheritance is the wrong pattern for software development, in my opinion. This is controversial, maybe still, but this is like, a lot of people in the industry would agree with this. Inheritance is sort of outdated as a concept. And there's a saying that is, I don't know who said this before, but if you just search composition over inheritance, this is a more recent, there's just a Wikipedia. So classes should achieve polymorphic behavior and code reuse by their composition rather than by inheriting a parent class. So basically, inheritance is just pointless, and it was a waste of time. Mel, where would we see this? You're not going to see this in React. You would see this a lot more in Python, because Python, when you get to more advanced stuff, it is extremely object-oriented. Python can actually have objects that inherit from more than one parent. So Python is way off the deep end with this stuff. It's like zebra can inherit from animal, but it can also inherit from, I don't know, what would be a sibling class to animal? Horse Kind of, yeah. But wouldn't horse inherit from animal too? So it would be like a chain, zebra, horse, animal. Yeah. Anyway, the point is that I would recommend, in general, when you want to organize your program, the idea of an object that puts together data and behavior is not a bad idea. Having an object that has some state, some data, some properties that contain stuff, and then also along with it, some methods that work on that data. Not a terrible idea. But to organize your objects and to put them into a hierarchy and to be able to substitute and blah, 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 it's usually better to organize your objects with has-a type relationships. So rather than inheritance, your objects should be composed of the things that they have. And this is a little harder to kind of articulate. I mean, I think part of the reason that inheritance has gone everywhere is because it's a lot easier to explain in like elementary programming classes. A duck is an animal, blah, 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 blah. So like people just kind of go into this pattern by default, but in practice, it's probably better if you're going to say a duck inherits from an animal. Well, what if you had a class called water animal and a class called land animal? Are those two inherit from animal, but which one is a duck? A duck inherits from both? That's what Python would say. Oh, it inherits from both, everything. And then which method from the water animal, methods in that one can collide with methods in the land animal? And it just becomes a mess. The world does not fit into a tree structure like this, where everything fits into a neat taxonomy. That's just not how anything in the real world really is. So it's probably much better to say that a duck, instead of is an animal, it can have a classification. It can have a species name and a this and a that. And all of that together is its classification. Sure, it can have a gender and a age and that other stuff. We can call that its demographic. I mean, it's a harder, more complicated word to put on that, but it's a better pattern of organizing because basically it kind of, instead of a tree structure like this, where you try to fit everything into one bucket of like, it has to be a version of this pattern tends to break down. And if you instead use like a pattern where something can have it can be composed of many components, preferring composition over inheritance, it generally scales better. That pattern is more successful in the real world. So that's, there's a lot more to object-oriented programming. There's a ton to it. I mean, there's, and this is going to annoy some people a lot if they watch this video, but like, I think like JavaScript attempts to resemble some aspects of an object-oriented language. One of them is it tries to do some form of inheritance, but the people who did JavaScript kind of like made their own version of it, which is pretty cool in one sense, but also extremely confusing and unique to JavaScript. So like almost nobody who writes JavaScript really understands prototypes. And if you don't believe me, try to understand JavaScript prototypes. Object prototypes. Prototype chains, a prototype-based language. If you really want to know all the details about prototypes, we're going to touch on a couple, but we're not going to go into a ton of detail about this. So this is object prototypes. And this is how JavaScript attempts to do its version of inheritance, of a template that can create objects, and then other templates which can sort of inherit the patterns of the parent template. Okay, it's related to the new keyword, and the class keyword. If you see class in a JavaScript file, we haven't seen this yet, but we've seen new when we did our new standard deck, our new dex.standard deck. We needed to use this new keyword. That means you're using a class-like object as a template to make a brand new object. It's like an object factory. You use the new keyword and you get a new object that follows a certain template. Every JavaScript object actually has a special property called prototype. It contains all of the properties of whatever it inherited from, whatever was used with the new keyword. If you do square brackets to make an array, that inherits from this capital A array's prototype. Or it inherits from this capital array thing effectively. So it has a prototype which has the property of an array. And it's tricky, but that's basically how every array has a dot splice and a dot pop and a dot push. It's because when you try to get a property on that array, which is not on the array that you just made, it then goes to the prototype of the thing that was used to create it, which is the square brackets in the case of the array, and then its prototype, and then its prototype. It's kind of like looking for a variable in the closest scope, and then the scope above it, and then the scope above it. But we're talking about objects that were used to create other objects. More recently, people have sort of ditched the weird style, which we're going to see in a second, and replaced it with this special class keyword, which looks much more similar to something like C# or Java, but it's kind of fake. And really what you need to take away from this is that classes are like templates for making objects. They give you an object that has predictable shape. Normal arrays are an example of this. They have push, pop, length, dot length. That's a property on every array. And you can do your own things like this that inherit, but I never do because it's a bad pattern for software development. So let's just give some examples of like how these things work. Let me go open a new Scratch file here. Yeah, Dominique, it doesn't, zebra wouldn't inherit from bugs. That's a totally different taxonomy or whatever, maybe a 6-legged zebra would inherit from 6-legged animals, but so would a bug, and so forth. It gets very confusing. Anyway, let's make a new Scratch file. Let's paste some examples. So this is the old super weird way. And we're going to talk about the this keyword in a second, but it's a magic word that is a object that is now a brand new object somehow related to the scope of this function. I don't know if I would. If you want to try to run this stuff, but again, I don't know if you'll see much of this after we get to the React stuff. This is like background. You might see this in, for example, we tried to use the card decks. We had to use the new keyword. And what the new keyword does, here's new thing. So I have a function thing which assigns two values to two properties of some magic this object, and that's it. It doesn't return anything. It returns nothing. But I'm saying my thing equals new thing. And if we look at, if we just log this, it's going to be basically what this object becomes. And this is just, whoops. Node Scratch. This is just how it works. JavaScript, for some reason, you assign to this magic this object. And when you say new thing, you get an object that has whatever this finally had at the very end of this function. And it's called this, which is the worst choice of a name for a variable, probably in the history of programming. It's literally the worst thing they could have named something for, a very confusing part of their language. The worst possible choice that they could have named it. It's called this. Yeah, that's not a joke. So yeah, if we log my thing, it's going to be an object which has whatever this ends up being. Now, here's where it gets super weird. If I then go back to thing, my function thing, and I go to its prototype, every object has a prototype, and I alter two properties on the prototype, this.prototype.b, and I set that to 3. And I go this.prototype or thing.prototype.c. I set that to 4. Now let me try console.log my thing again. I wonder if anyone has a guess what it'll be. My thing will now, wait a minute, what? Oh, wait a minute. Oh yeah, okay. So my thing has only the properties that it initially had. Yeah, Carolyn, it's called the TC39, and they're the worst. They're like, they come up with all kinds of nonsense because they're jealous of other languages, and then they stick them on the shoulders of everybody who's trying to do JavaScript. Look, I'm very, this is kind of a caricature. I really don't feel this strongly about it, but a little bit. Yeah, so we log my thing, it still has A and B, and I just forgot that no, my thing has only the properties that it initially gets. If I do my thing dot D equals 2, that will be added. So here's the new D, because I assigned it directly to a property of my thing. Now here's where it gets weird. If I do my thing dot C, what is that going to be? You're muted. It's going to be 4. And that's because it's just how the dot operator works with prototypes. So I made a new thing. It ends up being whatever this was at the end of this function. This was at the end of this function. So it has two properties, 1 or 2, but it also has a prototype. And if I do my thing.prototype, it's going to have everything I have assigned to things prototype, because it was the new thing was how I created it. So it kind of remembers that it is originally an instance of this thing. And it has the same prototype that capital T thing has. And that prototype will have B and C in it. What? Console.log my thing. Wait a minute. Maybe this, I don't even know how this stuff works. Prototype.c. Nope. Well, how the heck does this work then? 4. Anyway, I clearly don't even understand this stuff. I thought it would have a prototype.
Isn't it, I don't know, the slides is thing.prototype.c.
Yeah, but I thought my thing's prototype would be thing. Or
I don't know.
Man, I don't understand this stuff at all. I'm the wrong person to teach you about prototypes. How about that? Let's skip to the next thing. Fake classes, they kind of do this. So you don't have to do the weird this inside a weird magic function that becomes a class somehow, even though it says function. At least now with the newer JavaScript, you can use the word class. So, special kind of function, which is what it is. And
Can you just repeat that last sentence? I'm sorry, it was muffled.
you can use the word class instead of this, function that happens to mess with the word this. Yeah, and then it's the same. It's the same result. It's going to but you put all of the stuff that you would have put in that original function thing inside this block inside of a class called constructor. And it just makes the whole thing more complicated because it's like, oh, well, it's a class. You're all familiar with classes, but there's like all kinds of more magic details of this. I don't like any of this stuff. I try to avoid all of this stuff. If you're interested in this, number one, why? And number two, like I would, if you want me to go into detail about this, I can do some research, but honestly, I never use this and I have no idea how this prototype stuff actually works. Yeah, I mean, I do this for a living, so I've been doing it for a long time and I've avoided this stuff like the plague because I think it's just a horribly confusing design. It leads to all kinds of tricky bugs. There's a thing called prototype pollution. Let's see, prototype pollution. Check for prototype pollution. Is your app affected by prototype pollution in packages like Lodash and Angular? These are like leading JavaScript libraries that are written by some of the best JavaScript programmers. And they pollute the prototypes, the dangerous and underrated. So it's just best, all of this stuff is just best avoided. I don't like it. You don't need it for writing, good apps in React. If you want to do some really tricky stuff, then and impress people with how tricky it is, then it's good. But I've never found a use for this stuff that is really necessary or in any way even close to worth it. Because the thing is, you're working with developers who are not all going to be at the same experience level. And to throw this stuff at somebody and expect it not to be a disaster is naive. I mean, so anyway. All right, we'll come, I'll try to do a little more research so that I can explain what the heck is going on with that. But for some reason, related to prototypes, the thing.pro or the mything.c is somehow 4 after you run this. And I can't really explain why, because it's extremely confusing. So, okay, the word this is, you just saw it here. I guess we can go into a little more about this, but we're running out of time, which is probably a good thing. Yeah. Well, Carolyn, that might not be true. That's why I'm kind of throwing all this crap at you, is because you might see something super weird that says the word prototype somewhere, and it might be related to a bug in your program, and you'll have to know to that is a thing, and that we need to do some research, and that you might need to reach out for help, and that that kind of stuff. So exposure to this is still the reason I'm doing this, is because we still need exposure to this, even if we're not going to, hopefully not going to be using it very much. Yes, sorry, you're joking. Yeah, okay. Scope, remember scope, block scope, let and const, they are scoped to the if statement or a function or any block that they're in. Var, they are defined and they have the scope inside of a function. we just saw that we could define a variable with no keyword, and that automatically makes it global. And that was until we put the use strict at the top. In normal React programs, this is already taken care of. So if you forget to define it with your keyword, it's going to explode and say, you can't do that, which is good. That's what it should be doing. Related to scope, functions, not blocks, not if statements, they also create what's called an execution context. It's very similar to a scope, but there's only two kinds. There's the global execution context, and then inside a function, it is the function context, the context of that function running. If you really, really want a deep dive into what exactly that is, there's a whole article on this. This is more interesting, it's fairly interesting stuff, but it's going to be very confusing. There's a thing called a lexical environment and I forget what the other one is, but there is, when you're looking at the code, the actual lines of code in between the blocks, in between the braces are a lexical environment, and then there is the other context, which is, or the other sense, which is when the program's running, it's confusing. In the global execution context, this is called the global object. And so you can write this dot anything anywhere, and you get a magic object, unless you do some fancy trick to stymie that. But yeah, in the global context, when you're not running in any function at all, there's a special object called this. And in browsers, it's the same as saying window dot. So there's a special object in browsers called window. When you're in the global context, this is window. And don't mess with it. I mean, it's good to know this stuff, because when you see this, you'll know to watch out, or know to like dig into this, but don't write your own code that messes with this if you can avoid it, because it's incredibly confusing. When this is in a function, when you're in the execution context of a function, the value of this depends on how you called the function. It absolutely sucks. Good luck. If the function is called without the file or function starting with the magic use strict thing, this will still be the global object. If the function is called normally with the magic use strict statement, so if you just normally call the function, this will be null. If the function is called as a method of an object, so I'll demonstrate that really quick, just because knowing what a method of an object is, that's a good idea. So object, const my object, A1, B is a function. Console.log this. What did I get wrong? Oh, equals. My object equals this object. A is 1, B is a function that logs this. Dot, how about we log this dot A? When you call the function as a method of an object, so if I do my object dot B and call that as a method, this is going to be the object. So this dot A is 1. And if the function is an arrow function, though, that's not true. This is always whatever it was outside the function. So if I say arrow function instead of function word function, it's different. Now it's undefined because this is the global this. So if I said this dot A equals 5, now we would get 5. So the arrow functions ignore the inner thing. And so there are basically, at least I think, maybe only 4 different possibilities for what the value of this is going to be, depending on where you are. And that's just in the function context. Global context, it's the global object. Alina, I don't know if that's necessary because by the time we get to React, it's going to just kind of automatically be doing that stuff for you. So I would say yes, unless you are doing a setup that is provided for you, like the React, like create React app. It does all kinds of these setup things to make it better. And one of them is to make sure everything, it's not necessarily running in strict mode in the browser, I'm not sure, but you actually are converting more modern JavaScript to more older JavaScript and then running that in the browser. Very silly. It's all kind of set up for you though. So like, I don't know. I would have said yes a couple of years ago, but it might not be really relevant anymore. It's good to know it's a thing. It's not going to be needed probably in your capstone if you're writing it with React. And it's probably not going to be that relevant at all because it really just prevents certain things. I would say yes. I guess I would just say yes until we get to using Webpack and React and stuff to do that for us. Why not? It's better than not having it. So I guess extra credit if you start your files with use strict. Okay. Where is the quote? Oh yeah. Okay. This we can override the value of this in our function's execution context if we run the function using a special method that's on every function, .call or .apply. The first argument to either of these is the overridden value for this. And these are exactly the same except for one thing. With .call, all arguments after the first become the arguments to the function. So the second argument to call becomes the first argument to the function. The third argument to call becomes the second, and so on. With apply, the second argument, there's only one more argument, I think, and it's an array of the arguments to pass to the function. So it's the value for this and then an array. It sucks that there are two styles. You probably won't need this for your capstone or anything at all, which is good. Think if you want to try to remember the difference, think A for array and C for comma, separating your arguments. This is what call and apply look like. So we have a function that is assigning to this, and I want a special this. I don't want it to be the normal this. So I'm going to make my own this, and I will apply my func dot apply. So rather than just calling it normally, I'm going to apply it by and pass it the special this, and then my array of arguments. And the call would look like this. So instead of an array of arguments, it's just every argument is listed out flat like this. So 9 becomes the argument to here, and special this becomes the actual this inside the function. Yep. And with an arrow function, you can't do that. So special this, you can't, whatever you pass in here, the arrow functions don't care at all. The this is whatever the outside of the function the this was, which could be the global object, whatever. Arrow functions basically say, functions don't make a new this. They use whatever the this was outside of the function. And here's a quote from Stack Overflow. In my opinion, call and apply is completely confusing, and lambda arrow functions makes it unnecessary. So the arrow function will just completely ignore what call and apply do, and it will use the outer this, which is, I guess, sometimes still what you need. All of this stuff, again, like I said, my least favorite day. This method, functions have one more special method, .bind. It's slightly more useful maybe than call and apply. Bind still takes its value for this as the first argument. And the rest of the arguments are the arguments to the function, just like call. But unlike call and apply, bind doesn't run the function with those assigned with those variables and with this. It doesn't actually run the function. It just returns a brand new function where those variables are already filled in. So you could have a function that is called add two numbers, takes x and y, returns x plus y, and you could make a new function which is called add three by just saying, I want to bind this for this, who cares? We're not using it. You never want to use it if you can avoid it, pretty much. And the argument, the first argument, so this will become the first argument because this is this, we're not using it. This is the first argument. No, I don't want a dictionary. And once we bound this to the first argument, it's going to be called add three. So now this effectively runs add two numbers with the x filled in because we've bound it to not only a null for the stupid this, but its first argument. And then we can just call add three with 5, and we're going to get back 8 because add 3 has 3 bound to x, and when we call add 3, the only argument left is y. So it'll be 5 plus 3. So this might have a little bit of use. You know, I actually don't know if there's like a more modern way that makes this totally obsolete, but you know, this is called, sort of can be called partial application of a function. You're passing it some of the parameters it's going to need, and then making a new function out of that so that later on you can fill in the rest. This is sort of a functional programming technique. Other languages do this kind of thing much better, but they're like really esoteric academic languages, like really cool, like theoretical languages a lot of times. Okay, hoisting. When running, the interpreter internally moves all var declarations to the top of that variable's scope. Function declarations are also hoisted, which is why you can declare a function lower down on the page. You can call it up here and declare it down here. The important thing to remember is use let and const, don't use var. Using them out of order will error instead, which is less confusing and it's safer. So you can define a function down here, blah, you can call it up here, that's fine, because function definitions, just like var definitions, it's basically putting it up at the top and making it so that it's defined before anything else in this context. If you instead made an anonymous function expression like this, assigned it to a function, a variable containing a function like this, and then tried to call it up here, this is going to error because const declarations are not hoisted above. So if you define the function, it's fine to call it up here. If you try to assign it to a const, it's going to error. If you assign it with var, it's not going to, well, it is going to error, but it's not going to say blah is undefined, or it's not going to say blah doesn't exist. You can't use it before it exists. It's going to say blah is undefined because the declaration of this var thing will have been hoisted, but the assignment of the function will not have happened yet. That still happens down here. So at this point, blah will have been declared, but nothing will have been assigned to it. So don't use var because it's confusing. Okay, and we have a little time. We're going to do immediately invoked function expressions and the revealing module pattern. I'm kidding. We're not doing that today. That's scary sounding stuff. They are kind of cool, even though those are confusing. I like those actually a lot better than the other stuff we did today. But yeah, that's a mouthful, right? Anyway, so that's all. We're out of time. Reading, we're gonna, if you want to understand this better than I just explained it, the object-oriented stuff, the prototype stuff, this is probably the chapter to read. It sounds like I need to read it too. And if you want a programming project from the same book, you could check out the chapter 7. But otherwise, we'll see you back here tomorrow. The homework today is to do some exercises in Free Code Camp, get as far as you can, and take a screenshot and just upload that as your homework. So should be good. I'm just really trying to pitch the Free Code Camp exercises to everybody. Thanks for sticking with me through this. Sorry, I really am terrible at the prototype stuff and I'm the wrong instructor for that, but hopefully.
Okay. It's a lot of, I mean, I'm not glad you're suffering, but it's good to see that an expert, runs it. So it's like, here we are, here I am floundering, and it's like,
yeah,
okay, it's okay, so.
I mean, look, I like this stuff. The best thing I can say about a lot of this stuff is that it will not be really necessary for working with React. I think, Karen, do you ever really work with object prototypes or this or stuff that much? Do you work with?
The only time that I ever worked with this was in Angular, but
Okay.
when they did it, it was so you declare everything at the top. So if I had a variable that was named dog, I would have to say that like it was just a string or give it a value.
Good night, everyone. Yeah. That's what they'll say is like whenever you want to use var, you should be doing it kind of like this, like var blah here, right? And putting all of that stuff at the top of your files. Is that what you're saying?
Nope, it would just be no var, just so like you would put dog or just put blah and then a colon and then put either string or whatever you want it to the value to be.
Okay.
Did I lose you?
I don't even know what that, I would have to see an example and I don't, anyway.
Give me 1 second.
Okay, I don't want to keep everyone up, but yeah, let me.
Yeah, it's past my bedtime. I didn't take my Geritol yet.
Yeah, let's reconvene tomorrow. If there's like detail, I'll try to do a little more research on if there's anything I really need to touch on with prototypes. This, you're gonna see that it's still the worst possible name for it's I'm just mad about that whole thing. Bind is maybe useful in some cases. The other stuff, hoisting, that's, there's some gotchas here, but yeah, just we had to go through all this, and thanks for sticking with it, and have a good night.
Well, thank you, Karen. Take care, everybody. We'll see you tomorrow night.
Cool. Let's see. Did who was asking about the code that I couldn't figure out what was wrong with it?
I'm not sure. So I'm just going to send this to you in Slack. It's just a couple of lines.
Okay.
Not that it's a great example because I really haven't like used Angular, but that's. So that's how they declare all the imports would be above the variables, like whatever you were importing. Angular is really weird. It's like you have to do all this ng on init stuff.
Well, that's not even JavaScript. What is that?
That's like how they access everything. You create a variable and you define it, whether it's a string or a number or a Boolean or whatever.
That's like typing. That's like giving it a type or something.
Yeah. And then
that's some weird kind of TypeScript. Is that a TypeScript technique?
Well, so anytime you want to access the variable like dog or cat, you have to put this in front of it, and it has to be this dot, and then whatever you're going to do.
Weird. Okay.
Yeah.
Well, I've seen this in in old school React, you would have to do like you'd have to bind your functions, when you pass them in as props, you'd have to bind your components functions to the new prop or the new component, I think, or else this would get all screwy and it would mess things up. I don't
Right.
think that's relevant anymore. And honestly, I should do a search, like whether any of the code I worked on in the last like couple of years has ever had a this that I had to actually work on.
Let me see if I can find, I might have a sample real
Karen,
quick of just a couple of code lines.
Oh, Karen with an E, how's it going? Did you have any questions, or do you want to, have you been able to get set up with the free code camp? And or are you there? Oh, you said thanks. You probably peaced out. All right. Free code camp is the homework.
Okay, so here's just a single page that I sent to you.
Okay. Oh, this is like some Angular code.
Yes.
Oh boy. Yeah. Yep, classes. Yep. This is like the world of Angular. I don't like it. I don't like it. I don't like
I had to do it for well, you can probably, we could probably stop recording maybe before I say what I'm gonna say.
Okay, off the record.